Okay, welcome back. I apologize for that other video ending abruptly. Kind of ran out of time. I'll try to make this one a little shorter and make two videos that are happening. I'm also hoping this is recording it. We left off last time and I was like literally in the middle of this. So what you missed, which wasn't very exciting, was to find the third term. I'd plug a 3 in here, and 2 to the third is 8. 8 times 3 is 24. I recognize that this was times 2. That was times 2, so I sort of saw my rule. I knew my fourth term would be 24 times 2, and my next would be 48 times 2. And I checked it by plugging 5 in up here. 2 to the fifth is 32, and 32 times 3 is 96, so that worked. And then your job at the end of the notes was to do the same thing with these two rules. Again, two separate rules, and again, sequence is a list of numbers defined by a rule. So you're going to pause it. I'm not going to pause it. You're going to try both of these, and then you're going to unpause it, and you're going to check your answer. So pause now, and probably unpaused. Here are your answers. Okay, now we're going to move on to a very specific type of sequence called an arithmetic sequence, or you may think that word is arithmetic, and it sort of is. This is a little bit more basic sequence than the second type of sequence we're going to do called a geometric sequence. But arithmetic basically means adding. You have calculated the arithmetic mean. You've always just called it the mean or average, but you got it by adding. So you've also done a geometric mean in geometry, and we'll talk about that when we get to the geometric sequence. So again, if you need to pause to jot any of this down, you should. This is the official definition of an arithmetic sequence. And again, it's a sequence, which we already talked about, is a list of numbers with a rule. In this particular type of sequence up here, the arithmetic sequence, the rule is that each term differs from the previous term by the same fixed number, which is going to be called the common difference going forward. It's also called an arithmetic progression, and I can make up a couple very quick ones. In particular, if I start with number 8 and my common difference is 3, then I would be able to have my second term be 11, then 14, then 17, etc. And the rule or common difference is that we are adding 3 every single time. And there's our common difference, and we'll talk about how we can calculate that in a minute. But just so you know, the common difference doesn't have to be adding. I could also start with, say, an example of my first term being 5, and my next term being 0, and then my next term being -5, and my next term being -10. And I still have the same difference between them, but this time, as I go from one term to the next, I am subtracting 5 each time. And so again, I have a common difference. Each term differs by the exact same amount as I go. So it doesn't have to always be adding. It could easily also be subtracting. I have no idea what the computer just thought I wrote. But that was a little bit embarrassing. So the algebraic definition for this, again, this is notation for a sequence. This little notation is including all the values in that particular sequence. Is arithmetic, if and only if. And here is the big reveal, and this is what has to be true. And again, this, if we haven't seen this yet, this little two-sided arrow stands for if and only if, and I always really abbreviate that with IFF, if and only if. The difference between two consecutive terms is the same, and the notation of n plus 1 and n indicate any two terms in right next to each other. If every single term in this particular sequence, if the difference between every single paired term is the same, then it's an arithmetic. I do want to point out that this one comes after. Really having to focus on writing the word after right now for some reason. I'll fix that, has to come after this one in sequence. So a minute ago I started with 8 and I went to 11 because I added 3 and 14. So this would be first term, second term. Notice that this one right here is the one that would be in that first spot, and this term would be in that spot. So the actual difference I would calculate would be 11 minus 8, which is 3. And if I kept moving down this progression, I would then show that 14 minus 11 also equals 3. So these, each term, consecutive term, has a difference of 3, but it is important that this one in the front is the one that comes second or later in your particular sequence. Again, that D value, and this is going to be in your notes, it's on your formula sheet, that D value is known as the common difference. So this is another feature that we're going to just kind of talk about in generic terms. So if A, B, and C are consecutive terms of a sequence, so literally if I had a sequence that consisted of A, B, and C, then what I just showed you with numbers, what would be true would be that B minus A would have to equal your common difference, and then that C minus B would have to equal your common difference. And that could keep going. Notice that both of these happen to equal D, so if I wanted to do some pretty cool math up here, I could say, well, that means B minus A has to equal C minus B. And if I wanted to, because this middle term, and everybody knows that the middle is the best, so I'm going to add this B over here. If I add B over here, I'm going to have 2B, not ZTB. And if I add this A over here and come over here and add A, those are gone now, I would have 2B equals A plus C. And if I divide these by 2, then the middle term, you will notice, is the arithmetic mean of the two terms that are on the outside of it. So any term in the middle of two other terms will be the average or the arithmetic mean between those two terms. So just kind of a unique feature and characteristic of the arithmetic sequence to kind of know and to keep in mind. So we're going to look at the actual formula, and we're going to kind of try to build it as we go. We can look at this example over here as we work through this, but what I do notice, this is of course my, here's my, that's a crazy first term. So if I wanted to, I could come over here and say my second term looks like my first term plus, and in this case, my common difference appears to be plus 2 each time. And I'm going to actually attempt to erase whatever that is now. That is gone from us now. Good Lord. And from here to here, it's plus 2. From here to here, it's plus 2. From here to here, it's plus 2. So my common difference is 2. And if I want to do it the really long way, I'd be like 4 minus 2 equals 2. And I would be 6 minus 4 equals 2. And I could check that the whole way, but I don't have to. But it looks like the second term is the first term plus 1 common difference. So the first term plus the common difference. The third term of this sequence looks like the first term plus 2 common differences. The fourth term of this sequence is the first term plus 3 common differences. So if I want to talk about 1, 2, 3, 4, fourth term is the first term, and then there's 3 2's in separating them, or 6 that separate those two. So I think I'm going to erase some of this stuff because it's just getting a little bit messy here. And we don't need to see it over there anymore in this. I'm going to get rid of. So this is why these videos take a while, because I don't want that in there anymore. Gone. Perfect. Back to writing. So what we can kind of generalize is if I look at how many differences in relation to the term number, you notice this is one difference, term is 2. 2 differences, term is 3. 3 differences, the term is 4. I could possibly write a generic equation to find any term in the sequence based off of the first term and the fact that the number of differences is always 1 less than the number of term I'm looking at. So this is n is 4, and this is 4 minus 1. N is 3, this is 3 minus 1, etc. So this is a formula in your formula packet that you will be able to use. You do not have to have it memorized. Sometimes, sorry about that, sometimes you might see me accidentally do it like this, where I put that difference in front of n minus 1. There's reasons to do either. If I put the d here, you might accidentally be inclined to add these two, which would break order of operations because this is a multiply. If I put the d back here, you might forget that you could distribute it, but I'll probably try to use this one because I think that's the one that's actually on your formula sheet. Again, this u of n is your term value. This represents your first term or your initial amount. This is your common difference. And this n right here, excuse me, is your index. So we're going to look at an example right here. We'll do it one at a time. This is in front of you, so I'm going to try to do this in the next couple of minutes. So if I want to show this term as arithmetic, I just have to show the common difference is the same. So 9 minus 2 equals 7. Again, notice I take the term that follows and minus the term in front. Then I have 16 minus 9 also equals 7. 23 minus 16 equals 7. Check. Good enough for me. Moving on, find a formula for the general term. So the general term formula is first term plus n minus 1 times the common difference. So for me, that would be 2. That's my first term. We just found the common difference was 7. So that means I can keep this as n minus 1 times 7. Or if I'm fancy, this isn't actually fancy at all, I could put the 7 in front of n minus 1. Those are the exact same thing. If you're really excited about stuff, you could distribute the 7 and simplify from there. Find the 100th term. So I will find the 100th term by using the formula that you have copied down. So it's the first term plus 100 minus 1 times 7, or 2 plus 99 times 7. Order of operations means I have to do this first. 99 times 7 will be 693. Come on. And that would equal 695. I'm assuming that is correct. Last question is this a term of the sequence? So this is where I would set 828. That's the term I'm trying to find, equal to the first term plus n minus 1 times 7. And I'm going to solve for n. So first thing I need to do, and I can tell already that this might run out. That's okay. If it does, I'll just start it on the next one. I would subtract 2 from both sides, and I would get 826 equals n minus 1 times 7. Then I need to divide by 7 because I have to undo multiplication. And if 7 goes in evenly, then the answer is yes. And 7 does go in there 118 times. And if I wanted to add 1 to both sides, I would find out that was the 119th term of this sequence. So I'm going to pause it now, and I'm going to do a second video that will go over another example like this and some obviously further examples on your note sheet.